again, it's Robin from Security. In today's video I'm gonna present you a comparison between CVMs and C containers. Let's dive right into it. Before we dive into the specifics of CVMs and C containers, let's talk about why confidential computing is necessary in the first place. In traditional cloud computing environments, your data and applications are potentially exposed at various points. When you are running computation in the cloud, your data is vulnerable during processing, storage, and transmission. This means that cloud providers, system administrators, or even sophisticated attackers could potentially access your sensitive information. This is where confidential computing comes in. It aims to create a secure enclave within a cloud environment, a protected area where data can be processed without being exposed to the underlying infrastructure. Both CVMs and C containers are designed to address this need, but they do in so different ways. Now let's take a closer look at how these technologies fit into the broader system architecture. To understand the difference between CVMs and C containers, we first need to grasp the typical system architecture in a cloud environment. Let's break it down layer by layer. At the very bottom we have the hardware. This includes the physical components such as the CPU, memory, and storage devices. Next is the UEFI. This is a modern replacement for BIOS, providing a standardized interface between the operating system and the platform firmware. Above that we have the bootloader. It's responsible for loading the operating system's kernel into memory. Then comes the kernel, which is the core of the operating system. It has complete control over everything in the system. The full operating system sits above the kernel, providing a user interface and managing system resources. In a cloud setup, we often have either CVMs or C containers at this level. These provide isolated and secure environments for running applications. Finally, at the top, we have the application itself, the software that users interact with directly. In a traditional cloud setup, security can potentially be compromised at any of these layers. An attacker who gains access to the hypervisor, for instance, could potentially spy on all virtual machines it manages. This is where confidential computing steps in, aiming to create a secure enclave within the stack. But CVMs and C containers approach this challenge differently. Let's look at each in turn. Let's start with the confidential virtual machine, or CVMs. These create a secure enclave at the virtual machine level. In a CVM setup, the entire virtual machine, including its memory and storage, is encrypted. This provides a robust layer of security that isolates the VM not just from other VMs, but also from the underlying hypervisor and host operating system. One of the key advantages of CVMs is that they don't require modifications to the applications running inside them. This means you can often take existing applications and run them in CVMs without having to rewrite or restructure the code. A prominent example of CVM technology is AMD Secure Encrypted Virtualization, or CEV. AMD CEV is implemented directly in hardware, specifically in the CPU. It provides protection from the hardware boot up process all the way to the VM level. Here's how it works. When a CVM is created, a unique encryption key is generated. This key is used to encrypt all the data associated with that VM, including the memory contents and storage. The key is managed by a secure processor separated from the main CPU, ensuring that even the hypervisor can't access the unencrypted data. This means that even if an attacker somehow gains access to the hypervisor or the host operating system, they still can't read the data inside the CVM. It's all encrypted, and the decryption only happens inside the trusted CPU when the CVM is running. The beauty of this approach is its comprehensiveness. Everything inside the VM is protected, which provides a strong security guarantee. However, this protection also comes with some overhead in terms of performance and resource usage, which is something to keep in mind when considering CVMs. Now let's shift our focus to confidential containers, or C containers. These operate at a different level of stack, creating a secure enclave at the container level. Unlike CVMs, which encrypt an entire virtual machine, C containers typically encrypt specific parts of the system, usually just the container itself and its associated data. This more targeted approach can lead to better performance, but it also means that the security boundary is drawn differently. Confidential containers rely more heavily on OS-level features for isolation. They are designed to work with a containerized environment, which means they are a great fit for microservice architectures and other modern application designs that already use containers. A well-known example of technology enabling C containers is Intel's Software Guard Extension, or SGX. SGX provides a hardware-encrypted memory area for application, allowing specific parts of code and data to be protected. Here's how SGX works. It allows an application to create what's called an enclave, a protected area of memory. The code and data inside this enclave are encrypted, and the encryption key is managed by the CPU itself. When the application needs to work with this protected data, it's decrypted inside the CPU, processed and then encrypted again before written back to memory. This approach allows for very fine-grained control over what parts of application are confidential. You could, for example, keep sensitive algorithms or encryption keys in the enclave while leaving less sensitive parts of your application unencrypted for better performance. The trade-off here is that C containers often require more work from developers. You need to design your application with containers in mind, and you need to carefully consider which parts of your application need to be in the secure enclave. However, this extra effort can result in more efficient use of resources and potentially better performance compared to CVMs. Now that we have looked at both CVMs and C containers in detail, let's summarize their pros and cons. Let's start with confidential VMs. They are easier to implement for existing applications. You can often just lift and shift your current VMs into a confidential environment. They provide broader protection. Everything in the VM is encrypted, so you don't have to worry about missing anything. The resource overhead is higher. Encrypting everything comes at a cost in terms of performance and resource usage. You have less granular control. You can't easily choose to only encrypt part of your application. And now to the confidential containers. Confidential computing allows for more efficient resource usage. By only encrypting the data that truly needs to be confidential, you can optimize your computing power and storage. This approach offers finer-grained control over what's protected. It's especially beneficial in microservices architectures, where you can isolate and secure specific components without impacting the entire system. One drawback is that confidential containers often requires containerization of applications. If your organization isn't already using containers, this represents an extra step in your development and deployment process. Implementing confidential containers may require more effort to secure the entire application stack. You will need to carefully consider which components need to be in the secure enclave, which can be a complex task in large or intricate systems. And now to wrap it up, both of these technologies offer powerful tools for securing the applications in the cloud, each with its own strengths and trade-offs. The choice between them will depend on your specific security needs, your application architecture, and your development workflow. If you're dealing with legacy applications or need comprehensive protection with minimal changes to your code, CVMs might be the way to go. If you're building modern containerized applications and want fine-grained control over what's protected, C containers could be the better choice. And there you have it. I hope you found the comparison useful. If you have further questions, write them down in the comments. See you next time.